By 2030, there should be less than 10,000 parts per million of CO2 in the atmosphere, and our target value is less than 10,000 parts per million. By 2050, the pipeline should have been fully retrofitted to transport hydrogen only and should be transporting an equivalent amount of hydrogen compared to the amount of natural gas it currently transports. The retrofitted pipeline should have a lifespan of 30 to 75 years, and our target value is 50 years. The pipeline should cost around $3 billion, and our target value is $2.5 billion. From the case study of oil and gas pipelines, the average budget was $3.4 billion, but operating with hydrogen is much more expensive. Pipeline projects using fossil fuels would normally gain a lot of opposition from indigenous people because their land is being taken, and in the event of oil spillage, there would be negative environmental impacts. Our pipeline uses hydrogen instead, so there would be opposition, but it would definitely be a lot less because hydrogen spillage wouldn't have massive negative environmental impacts. Large corporations like Hyundai have started investing in hydrogen transportation by bringing hydrogen-powered vehicles into the commercial market. Commercially sold hydrogen-powered vehicles in use would decrease the amount of greenhouse gas emissions in units of tons.
We will be able to get the hydrogen by electrolysis of water and can use wind turbines to create energy to perform this process. We will use the existing pipelines as the path to transport the hydrogen, and they will be retrofitted in order to safely transport it. The hydrogen will then be used as a clean energy source. It can be used to power hydrogen cars, generate electricity, and hopefully replace the sources of energy that cause a lot of greenhouse gases. As hydrogen is used as an energy source, the technology that will use it will increase, causing it to be a more and more energy efficient source and a viable option. Through transitioning to hydrogen pipelines, the goal of net zero greenhouse gas emissions by 2050 will be able to be met. The pipeline will be needed to retrofit it to be able to carry liquid hydrogen, but until then we'll be able to carry a blend of natural gas and hydrogen. With the proper modifications, the pipeline should have the ability to last a minimum of 50 years.
Our goal is to use the green hydrogen, but the highest cost and immediate manufacturing process we prefer blue hydrogen in the first 14 years. Blue hydrogen is made from the petroleum gas, which releases a small amount of the CO2. Our goal is the zero emission, but the blue hydrogen is to use for transition. We will invest $6 billion in the first 7 years, and then we will invest $2 billion in the remaining 7 years. We do the investment to convert to green hydrogen. Green hydrogen will invest $2 billion over the first 7 years. He was greatly increased with the total investment of the $12 billion. According to the previous case about pipeline budget calculation, we get about $40 billion. With the other expensive, our project is about $80 billion.
Our main goal of using hydrogen as our main reusable energy source is to transition from the energy sources we are using now that are accumulating to our greenhouse gases in the environment to hydrogen instead. This would be implemented by switching transportation methods like cars, buses, and ferries, industrial energy, and natural gases to hydrogen instead. Green hydrogen that will be produced will greatly impact the GHG emission problem that we have in today's world by helping with this reduction process and aid in our goal to reach zero emission by 2050 due to hydrogen gas burning cleanly. As the implementation of hydrogen-fueled cars and buses come into play, adding about 100,000 hydrogen fuel cell electric cars will reduce GHG emission by 294,000 tons. On the other hand, incorporating about 5,000 fuel cell buses will bring 450,000 tons of carbon monoxide down from the environment. There would be many benefits to using hydrogen as a main source of energy, as there would be many job creations coming from it. There would be roughly around 1,000 new job positions created due to the power systems and the hydrogen fuel cell sectors in British Columbia alone. As hydrogen is a fairly well-rounded source of energy, it would be able to be reused for many years and will greatly help with lowering GHG emission in the environment. The design and the fuel cell sectors will roughly generate $200 million a year for the sector revenue for Canada. Lastly, hydrogen is a fairly efficient source of energy, and since it burns very cleanly, it doesn't add external greenhouse gases into the environment.
Will be repurposed by upgrading their strength and using the existing pipeline system to move hydrogen around the country. Our current pipelines are already suitable for transporting blends of natural gas and hydrogen at low percentages, around 15 and 20%. This is useful as in the short term hydrogen can already be transported across Canada, and the move to pure hydrogen can be done in phases, while certain parts of the other pipelines are upgraded with higher quality steel in order to transport 100% hydrogen. In general, the construction of a new pipeline project can take up to 18 months or more, depending on the length of the project. With our idea, a new pipeline is not created. Instead, another pipeline will be retrofitted in order to be capable of transporting hydrogen. This retrofitting will come in phases, as some amounts of hydrogen can already be transported on day one of the project. As the project goes on, different lengths of the pipeline will be retrofitted to carry pure hydrogen, until eventually the whole pipeline can transport 100% hydrogen. If construction is rolled out this way, there will be limited interrupted service and the hydrogen can be transported from the very beginning by blending it with the existing natural gas.